So let's use Pythagorean Theorem with absolutely no formula. Check this out. Like, please.
Are we listening to a song?
Hmm?
We listen to a song?
Pause. Alright, guys. Quiet down, please. Okay, with my cursor, because I want to still record myself. Does everybody see that this is a right triangle? Please stop talking. Does everybody see that this is a right triangle? Off the sides of a right triangle, we have legs. So here's a small leg, and here's a small leg. This leg, if I take the side of the leg and I put the same length on this side, it creates a square off of the leg. Here's the longer leg. If I take the length of the longer leg and extend it out here, it makes a square. And this side is called the hypotenuse. Where did my picture go? All right, so let's watch this. All right, let's pause that for a second. So, what happens? So this square right here and this square right here fits perfectly into the larger square. That's pretty cool. What do you mean it doesn't make any sense? They just proved it. Right? And okay, so let's not use water. If you had like Legos in here, like 1-inch cube Legos, and if you had all the Legos that were in this square and all the Legos that are in this square, if you took those two Legos, they would all fit perfectly into that square. Perfectly. No? I'm going to prove it right now. You ready? Okay, let's watch the rest of it. Isn't it? Pretty cool, huh? It fits perfectly. All right, so check this out. I'm going to show you, I'm going to prove it to you right now, because Matt is a skeptic. All right, so forget the A, B, and C in here. I wonder if I can take them out. I can't. Okay, so what is the side of this square right here? 4. So if this is 4 and this is 4, then what's the inside here? 16. 1, 2, count the squares. 1, 2, 3, 4. Right? So if this is a 4 by 4 square, the area inside of the square is how much? 16. Let's count this one. This side is 3. That means this side is 3. So the inside of this square is 9. Now, from the video, we learned that this square and this square will fit perfectly in this square. So how many squares do I have in here? 25, because 16 squares and 9 squares makes 25 squares, correct? Right? Well, if there are 25 squares in here, how much is this side? It's 5. Correct? Because the 5 by 5 is 25, or the square root of 25 is 5. Now watch this, Matt. Are there 25 squares in there? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 times 5 is 25. What do you think? It doesn't look like it, right? Doesn't look like it, but it's true. Pretty cool, huh? Breathtaking. Alrighty. So pencils down. My first step is going to will be to. We're going to take this out right here. We don't want this. No. We don't need to set up an equation. All right, draw a right triangle. I've got it. Let's label it. So if this is 10 and this is 6 and this is C, C is my hypotenuse. So let's make this side be 6 because it's smaller, and this side be 10. All right, if this side is 6, if I extended out a square, what would be the area of that square? Yes, 36. And if I extended this leg out, what would be the area of this square? 100. So if I extended out the big square, what would be the area of that square? Because two smaller ones make up a bigger one, right? 136. If the area inside of this square is 136, what is the side of the square? Root 136. Somebody asked, what? Isn't it very simple? What is root 136? Somebody estimate that for me. 6. It's somewhere between 11 and 12. How do we know?
Because 11 times 11 is 121.
11 times 11 is 121, and 12 times 12 is 144. This is somewhere in between the two. So what are you guys going to guess? 11 point what? 11. I heard 11.6 first. Let's figure it out. 136 square root 11.6. Actually 11.66. I didn't say it. It's actually 11.66, so it would be 11.7. Matt. I want you to do it just like this. Okay? Let's do, so you guys go ahead and write that down for me. Alright, let's do another one. Pencils down. This one looks a little bit different. Okay, so if I don't know A, which one you want to make A? It doesn't matter.
The bottom.
The bottom. Okay. I'm going to call it X. We'll call it A. That's fine. I'm just trying to get away from the formula. And B, that would be this one, right? Square root of 8. And C, no writing. Square root of 18. Everybody understand how I labeled it? Right? If it told me the B side is the square root of 8 and the C side is the square root of 18, is that correct?
Yeah.
All right, let's draw pictures. And by let's, I mean me. So this side is, if the side is root 8, what's the inside? 8. And if this side, yes. Because I'm pointing to the hypotenuse. And this side, if the sides of this square are root 18, then what's the area of this square? 18. And I don't know this one. How do I, if I know the area of this, guys, if I know the area, this is 8, plus something makes 18, how would I find this one? You would subtract. Andrew, what'd you say? What'd you say? If you have 2 and 5, 2 plus what makes 5? 2 plus what makes 5? 3. How did you figure that out?
Added a 3.
You added a 3. But what if you didn't know it was 3? What would you do? You'd take the 5 and subtract 2, and that gets you 3. Right? So 8 plus what makes 18?
Oh, 10.
10. Or 18 minus 8 makes 10. Correct?
Yes.
So my whole point is, if you want the big one, you have to add the 2 little ones. If you want a small one, you have to take the big one and subtract the other small one to get the small one that you want. So if the area is 10, what's the side? Square root of 10. Which is?
2 times 5.
Yep. What do you think?
2.5.
No. 2.5? What's the square root of 9?
3.
3.
Oh,
Well,
3.5.
I'd say 3.1.
Are you sure?
Let's see.
Let's say 3.5.
3.16.
Let's round it.
Okay, write that down, guys. Okay,
Because you have to subtract 8, right?
right? 18. Okay. Frankie, if I don't know what 10, if I don't know that, 8 plus what makes 18? 10. Or doesn't 18 minus 8 also equal 10? That's how. Alright, write that down, guys. Recording. Alright, so lights on. I want to see you guys draw me the triangle. Draw me the triangle and label it, please. Recording. Okay, so I draw myself a right triangle. I'm actually going to make a really pretty one. Here's my right triangle. It is?
Yeah.
You can handle it. Alright, so if this side is 8, and this side is 6, doesn't matter which one, right? Then the area of this square is what?
8.
No, if the side is 8, then the inside is 64. And if this side is 6, what's the area? 36. So how do I find the area of this square? This plus this, guys, this is adding, right? But if I can't add them, what do I do? Subtract. What's 64 minus 36? This plus this is this. I don't have this. This 36 plus what? 36 plus what makes 64? How could you figure that out? You could go in the opposite. 64 minus 36 must be... Andrew, are you understanding? No? I need you to understand this. And as soon as you see it, you're going to be like, oh. What? You messed up? Let's use easier numbers. Guys, I need the talking to stop, please. If this area is 10 and this area is 4, what's this area? Four plus what? Because you have to add these, right? 4 plus what makes 10? How did you do that? You add it in your head. Well, when you can't add it in your head, 10 minus 4 is 6. Do you see that? Andrew, yes? 4 plus 6 is 10? Yeah? It's the same idea. So if I don't know what this is, I can either add 36 plus, I could count it on my fingers, or you could just subtract. So that's 28. Does that make sense? Does 28 and 36 add up to 64? Yes. 36 and 28 make 64. So if the area of this square is 28, what's the side of the square? Root 28. It's not 28, it's root 28. Alright. Guys, I'm going to say this one more time, and I did this in the back. If I tell you that the side of this square is 3, what's the area of the square? 9. Couldn't I also say that this is root 9? Isn't root 9 times root 9 9? So what's the side of this square? Root 12. Okay. I think we're good. Try 4. For number 4, am I going to have to combine to get the bigger side or subtract to get the smaller side? I'm going to have to combine. Combine to find the C. What about this one? Am I going to have to combine or subtract? Subtract. You already have the C. You already have the big one. If you have, yeah. Nope. All right, let me do this one. I'm going to draw my triangle and label my side. I don't know what C is. It doesn't matter which one you put here. Okay, my turn, guys. So if this side is root 5, what's the area of my square? Okay, you guys are having a hard time with this. No. Root 5 times root 5 is 5. Root 10 times root 10 is 10. The C is 15. So C equals root 15, which is how much? 3.8, you think? 3.9? Because it's almost 16? Yep. Yes. That makes sense. 1129. We're almost done. What about this one? Let's draw a triangle for this one. Draw my triangle, label the sides. This time I have the C, so the big side is 12, my hypotenuse. 6, and I don't know this one. Using my color to get area. If the side of my square is 6, what's the area of the square? 36. And if the side of my hypotenuse is 12, what's the area? 144. If I know the big square and a little square, how do I find the other little square? 36 plus what makes 144? 108? If the area is 108, what is the side? Root 108. Somebody estimate root 108 for me.
121, 100, 10 and 11 is going to be 10,
Point,
3.
I would say 3.
4.
I don't know, let's see.
Definitely 4.
108, 10.39, so it's more 10.4. Questions? Anybody have questions? Yes. Okay. So what did you learn today?
With pictures.
Pythagorean theorem with pictures. How is area involved with Pythagorean theorem? The squares, right? The squares of the legs. All right, on your assignment sheet, explain when you combine or when you subtract to find a missing side of a right triangle. When do you combine?
When you have the A and B.
When you have the small sides. When do you subtract?
We have A and C or B.
When you have B and C or A and C, right? When you have the hypotenuse, you subtract. When you have A and B, you add. Good job, guys.